Okay, in this problem, we're basically looking to see one possible solution for this triangle among these answers. Now, I'm noticing that they give me a side, and an angle that is not in between them. So this is a side angle situation. And this one is very special. It's called the ambiguous case. We always use the law of sines to do it, but the reason why they call it the ambiguous case is because sometimes these numbers don't make a triangle, or sometimes they make one triangle, or sometimes there will be two triangles. So this picture is actually really distracting. So I'm going to take the information off of the picture, but I'm going to draw my own picture and follow the procedure that I always do when it's a side angle. And here's the procedure. As soon as I see that it's SSA, I draw myself a horizontal line, and I put an angle on the left. Alright, so the angle that they gave us, I always put that on the left, right here. Alright, so that is angle Y in this case. So that means that this side over here, which I always put as a dotted line, must be the 40. Okay? Now, I put this as a dotted line because we don't know whether this line will make a triangle or not, or will it make one triangle, or maybe it will make two triangles. Maybe it will go on the inside and make a second triangle. Okay, so I put it as a dotted line because we're not sure. I think of it as a rope. Okay, so if I say the rope is doing this, I'm talking about this side right here. Okay, now we're given one other side, and that's this. I always put that side to the left. So I will put that 43 right here. Okay, that makes this angle X, right? Because this side with the 43, that's XY. So that means this is XY, and I already have Y, so that must be X. So this must be Z. So this is the way I'm going to draw my picture. This is the way I always draw the picture. Okay? Now, the next thing we have to do is check. Check to see if this will make a triangle at all. And if it will, can it make two triangles? And the way we check is we compare the rope to the height of the triangle. Okay, so I'm going to call this H. This is the height of the triangle. And we can find the height by doing r sine theta. Okay, I just think of it this way, but r stands for radius. For some reason I think of this side as a radius, like it's rotating around y. Okay, but when I say r, I'm talking about the 43. So the height is going to be 43 sine 68. Okay, and maybe write down this little r sine theta formula, by the way. So I can just put this in my calculator, see what the height is. Okay, so 43 sine 68, that turns out to be 39.9. Okay, so the height is 39.9. Okay, so that's really important because we have to ask ourselves, will the rope reach the ground? Is it long enough? Well, the height is 39.9. Well, the rope is 40. So it does reach the ground, all right? The rope is just a little bit longer than the height. Now, if somehow it were exactly 40, if the height was exactly 40, then there would be only one triangle because the rope would have to be straight down. It'd be a right triangle. But because the rope is a tiny bit longer than the height, then actually we can make two triangles. And that turns out to be important to this problem. Okay, we can make one triangle the way it is over here on the left, but we can make a second triangle, wait, I said left, the way it is on the right, but we can make a second triangle going inwards. Okay, that's what happens if it's longer than the height, as long as it fits. It has to be shorter than this 43. If this was 50, if the rope was 50, sure, it would easily reach. But would 50 fit underneath a 43? No, 50 would stick out. But 40 is shorter than 43, so it fits on the inside. That's what it takes to make two triangles. Okay? So that's the situation we have. We have one triangle that's outer, like this, but we have a second triangle where everything is the same except for the rope is bent inward. Okay, so see how the rope is like this? This time I'm going to draw the rope in like this. Okay, so the three pieces of information they gave us will stay the same. This angle is still 68. The rope is still 40, just swung inward, but this side right here is still 40. And this R, the R side over here is still 43. Okay, all that is the same. However, everything else has changed. So see how this angle and this angle, they're not the same size. So I need two names now. Okay, so I'm going to call this x2, alright, because it's a different size x. And I'm going to call this z2. Alright, this side over here, I'm going to call this side x. Okay, that's a lowercase x. But this side over here is shorter. It's different. I'm going to call that x2. Okay, so I need to actually solve for both of these triangles to see if they match. Alright, so I'll start with the triangle on the left. I need to find angle Z, angle X, and side X. I'm picking angle Z first because it's across from something. I wouldn't want to pick angle X because I'd have two unknowns across from each other. So since I'm looking for an angle, I'm going to put my angle in the top. So the law of sine says the sine of angle 68 over the opposite side, which is 40, should equal the sine of angle Z, that's what we're looking for, over the opposite side, which is 43. So I'm trying to get Z by itself. So if I multiply both sides by 43, that will get me one step closer, because the 43's will cancel each other out. So that will leave me with sine Z by itself. So I'm just going to put all this in my calculator. 43 sine 68 over 40. Okay, I'm getting 0.9967. By the way, use 4 decimal places until the very end. So 0.9967. Okay, so now if I want to find angle Z, alright, if I want to get angle Z out of here, I need to do the inverse sine. Okay, maybe I'll just put this sideways because I'm running out of space. So the inverse sine of 0.9967 should equal angle Z. Alright, that's how you get an angle out. So I'm just going to put this in my calculator. So inverse sine of 0.9967. By the way, make sure your calculator is in degree mode. Sometimes calculators revert to radians. So we have degrees here, so you got to be in degree mode. So I'm getting 85.3. So that is angle Z, is 85.3. Okay, let me see if I can squeeze that in. 85.3. So now I can easily find angle X. These three angles have to add up to 180. So I can just subtract from 180. So 180 minus 85.3 minus that 68 that we had from the beginning leaves 26.7. Okay, so angle X is 26.7. Okay, so I'm going to have to erase the law of sines because I need the space to do the law of sines again. So now I need to find side X here. So since I'm finding a side, I'm going to put the side in the top this time. So the law of sines says 40 over sine 68 will equal X over sine 26.7. Okay, so the easiest way to solve for this is to multiply both sides by sine 26.7. So that way the sine 26.7 cancels out. That leaves X by itself. So if I put this in my calculator, that should give me X. Alright, so that's going to be 40 sine 26.7 divided by sine 68. Okay, so that's 19.4. So X is 19.4. Okay, so this group of numbers is one possible solution. There's another that we will make out of that we can make out of the purple triangle. But if we've already found the solution, then we'll stop. So, have we found the solution? Oh yeah. Remember, I called this X, and they're calling it YZ, but that's the same thing. So this is basically X right here. So let's see. Only one of these has 19.4, so I'm going to focus on that. That one has angle X of 85.3. My angle Z is 85.3, so that doesn't match. These are backwards. So this answer does not work. Well, it doesn't match what I have. I shouldn't cross it out. Okay, so the answer I found doesn't match any of these. So that's what tells me that I have to keep on going and solve the other triangle, the purple triangle. So that's what I'm going to do now. after I make some space. Okay, so again, for the purple triangle now, I need to find the same stuff, but I will call this angle Z2. Alright, I need to find that. I need to find angle X2. And I need to find side X2. Alright, the same stuff, but for the purple triangle. Alright, now here's the one trick. Alright, most of this I will follow the same procedures that you just saw, except for the very first step. You need to understand the angle that's formed by the rope here at the bottom. You see the 85.3 that you get when the rope is on the outside of the triangle, and then you have this angle Z2. Or really, I could just say see angle Z and angle Z2. The angle you get when the rope is outside and the angle you get when the rope is inside. These two angles are always supplementary. Okay, maybe we should put that in our notes right now. Okay, this is key. These two are supplementary, meaning that they have to add up to 180. So I'm going to use the fact that the first one is 85.3, and I'm just going to subtract from 180. So if I do 180 minus 85.3, that gives me 94.7. Okay, so that tells me the other angle. Okay, so that's a lot easier than doing the law of sines, so that's very helpful. Okay, so we get 94.7. Now we can find the other angle. We still don't need the law of sines yet. Now we have 2 out of 3 angles, so we can subtract from 180 now. So now I can do 180 minus 94.7 minus the 68. So that is 17.3. Okay, so angle X2 is 17.3 degrees. Okay, so now I can find X2, alright, the little side down here. And for this, I will actually have to use the law of sines. So since I'm looking for a side, I'm going to put the side on top. So we will have 40 over sine 68. And that should equal X2 over sine 17.3. Alright, it's the side over the sine of the angle across from it. So now I can just solve this for X2. And the best way to do that is to multiply both sides by sine 17.3. Alright, that way the sine 17.3's cancel each other out, leaving X2 by itself. So if I just put this in my calculator, that's going to give me X2. So 40 sine 17.3. Close your parentheses, and that's over sine 68. So divided by sine 68. So that gives me 12.8. Okay, so this is another possible solution. The first one didn't work out, so I'm hoping this one will match. So let's see. Let's start with the 12.8 because that's our YZ. And I do see 12.8 right here. Now that goes with an angle X of 17.3, which is what they have, and angle Z of 94.7, which is what they have. So the answer is the third option.